Hi, this is Sean Chua from simplechamconcepts.com. Welcome back. Today we're going to discuss on a very important chemistry topic known as chemical bonding and structural properties. In my opinion, if you want to master chemistry and do really well, it's important that you know chemical bonding very well. It's a prerequisite, or say it's a building block of chemistry, because a lot of topics, the application topics, will be interrelated back into chemical bonding. Now, a lot of students actually commented and feedback to me that they find chemical bonding very difficult to learn and to master. They don't really understand what the school teachers are teaching back in the school after a while, as well as when they're reading their own reference textbooks. Now, in my opinion, it's very important to have a structure to learn chemical bonding. I will propose 3 steps. Step 1 is to have a flow chart, to have an overview framework on the whole topic called chemical bonding. Second step is to get into the details, to understand all the concepts and the keywords associated with it. Last but not least, which is the third step, is to go back to the framework, the flow chart that you have in step 1, and look at it again so that it becomes a summary. In that way, you'll be able to master chemical bonding really well. Let's get started and see what's the framework like. Now, so I'm going to draw it on the board over here. This will then be bonding. We all know in bonding, there are 3 types of bonding. So, you have your ionic bonding, you have your covalent bonding, and you have your metallic bonding. Now, we're going to then next take a look at what are the keywords associated with the concepts in these 3 types of bonding. Let me illustrate. Now, ionic bonding is formed between metals and non-metals, meaning elements that are metal as well as elements that are non-metal. Usually they are formed this way, metals and non-metals. And what happens is there's a transfer of electron from the metals to the non-metals such that opposite charge ions, such as the cations and the anions, are formed. So you have your ions, your oppositely charged ions that are formed. Now, these oppositely charged ions will then be held together by your strong electrostatic forces of attraction. Strong electrostatic forces of attraction. And this is ionic bonding. You then have your ionic compound. Now, then you have your covalent bonding. Covalent bonding, they are formed between non-metals and non-metals, and they do so by sharing of electrons between the atoms that are involved, and after sharing they form molecules. So these are the keywords associated with covalent bonding. Metallic bonding is slightly different. In metallic bonding, it literally involves only your metals. It only involves metals. In fact, all metals will have metallic bonding. Now, what happens is, in metallic bonding, the atoms that are involved, the metals, they have valence electrons. And the valence electrons will be delocalized into empty spaces. We call them the sea of delocalized valence electrons. And this sea of delocalized valence electrons will then be surrounding the positive metal ions. These ions are formed from the metal atoms. After they lose their electrons, they will then form your positive metal ions. And the forces holding them is still your strong electrostatic forces of attraction. So, these are the 3 types of bonding. If you take a look, there's some similarity. Yes, there are a lot of differences in terms of the keywords that describe the concepts. on how these bonds are formed. Now, so this is chemical bonding, the three types. Do note that in an exam, we also ask you about structural properties. Now, they are slightly different, but it's a build-up of the bonding. Now, in terms of structural properties, ionic compound will then have giant ionic, sometimes we call it crystal, lattice structure. Whereas the covalent compound, it all depends whether, in terms of the covalent compound or the covalent molecules, whether they are small or they are big. If they are small, we tend to call it small covalent molecule or simple molecular structures. When it's big, we will call it macromolecular structures, macromolecule, or simply giant molecular structure. So these are the two types of structures under covalent bonding. Metallic bonding, the structure that they are formed is known as giant metallic lattice structure. Now these are the keywords that we are looking for. So make sure that in an exam you give them these keywords. Now the last thing that I would like to discuss is the structural properties. Once you know the structure, then you need to be able to tell them some of the physical properties that is associated with it. And these are the common ones that you must know. You're always tested on that. Now, ionic compound, the first physical property is that it tends to be soluble in water. Most of them are soluble in water, usually. And the second one, they're insoluble in organic solvents, such as your oil. Third, they conduct electricity in molten or aqueous state. These are the three physical properties of ionic compound or giant ionic crystal lattice structure. Now, the simple molecular structure, the physical properties, kind of being the polar opposite of your ionic compound. They tend to be insoluble in water for most of them. They tend to be soluble in organic solvents. Third, they do not conduct in any state. This for simple molecular structure. Giant molecular structure is important that you know there are three main ones that you'll be tested on. I'll just put 1, 2, and 3, and each of them will have similar yet have their own differences. All right, similar properties and different properties. First one you need to know is called diamond. Next you need to know is graphite. Last one is your silicon dioxide, your SiO2, silicon dioxide. I'll not talk about their properties over here, probably leave it to another video or another blog post. So feel free to check out our blog and our videos. Now the last one that we're going to talk about is metallic bonding. So metallic bonding over here, you have a giant metallic lattice structure. The first property is that it is malleable and ductile. So malleable means the ability to be beaten into shapes or hammered into shapes without breaking. Ductility or ductile is about the ability to be stretched, all right, without breaking. Now, second property we're going to talk about is conductivity. So metal, they conduct electricity in both the molten as well as the solid states. So these are the physical properties for the giant metallic lattice structure that you must know. So, let me take a look again. So this is the flow chart. So it's good to have a bird's eye view on what is happening here. Relearn them, go into the concepts, learn them, look at the keywords again, familiarize them, and then third step, come back here and relook into this. This become your summary itself. Alright, so in this way you can master chem bonding really well. I hope you enjoy yourself today, alright, and learn a lot from this video. Feel free to rewind it, alright, and keep reviewing it. It's good for you to copy down on a piece of paper, a foolscap paper, and be part of your note. Alright, feel free to share this with your friends, and I look forward to seeing you in the next video. Thank you.